Differential equations of the form dA dt is equal to Ka, and these are separable. This might include equations of the form x dot is equal to kx when dealing with motion, as we'll see later in the course. Suppose a population A is increasing at the rate of 7% per annum. We can say the rate of change of A is proportional to itself. In other words, the larger A is, the larger the growth in terms of numbers, because if you have a population of 500,000, 7% of that is half of 7% of a million. So when the population is larger, the numbers grow more quickly, but the percentage is the same. So here we can write this as dA dt is equal to 0.07a, with the 0.07 being 7% as a decimal. This population growth can be written as a differential equation with boundary conditions. So we have the equation itself here, and then the population A at time 0 is usually written as A naught. We can now solve this equation to find A as an exponential function. So starting with the ADT is 0.07a, we separate and integrate as we've seen before. The left-hand side will give us the natural log of A. The right-hand side, 0.07t plus a constant. If we then take exponentials of both sides, we know that the exponential function and the natural log function are inverses. So when we do that to this, we just end up with A. And on the other side, we have e to the 0.07t plus a constant. Now, we know the index law, a to the m times a to the n, is a to the m plus n. All we're doing in going from here to here is splitting this by going in this direction on the index law. Just have a look at that if you're not sure. And so a is equal to e to the c times e to the 0.07t. Since a is a naught when t is equal to 0, note when t is equal to 0, this part is just equal to 1, it's e to the 0. And so we get that e to the c is equal to a naught, and therefore we end up with a at any time t being equal to a naught, that's the time at the beginning, times e to the 0.07t. And then we just stating this at the bottom. If dA dt is equal to Ka, then a is equal to a naught e to the kt, where a naught is the value of a when t is equal to 0.